Okay, so you did some work with the relationship between velocity, speed, and acceleration. And I'd like to start right here in this first statement to make sure that this is 100% clear to you, because this is going to matter later. Speed is the absolute value of velocity. Speed is the magnitude of velocity. Speed is how fast you're going. Velocity includes not just how fast you're going, but remember also direction. So if we're on the x-axis and the sign of the velocity is positive, that means to the right. Speed doesn't care about sign, it just cares about the number. So we don't need to talk about that, but what we should be thinking about here is what effect does taking the absolute value of a function have on its graph? And we have talked about this. So if you see if you can dredge through your memory and have some recollection. I'm going to be drawing a sweet picture. Okay, this is some function. I'm not even bothered to name it. What happens to the graph here if we take the absolute value? Well, this is what happens. Because, just like with numbers, the absolute value makes everything positive. All of this graph needs to become positive. So what happens is we're reflecting across the x-axis. So that piece right there that's below the x-axis, that's now above. This piece over here that's below the x-axis, that's now above the x-axis. So graphically, we do the same thing as we do numerically. Okay, so remember that because we're going to need it here when we're going through our stuff. So numerically, the velocity is 1, 2, 4, 8, 16. You take the absolute value of those, you get 1, 2, 4, 8, 16. Those are the same. How about graphically? Well, this graph right here, when I take the absolute value of it, I get the same graph, yes? Yeah. This graph is positive because this graph is above the horizontal axis, or x-axis, I guess, if that's what you want to call it. So, in this situation, I'm not going to write in the blanks, I'm just going to underline here. Velocity is positive. Why? We're above the horizontal axis. Okay? Looking at this graph, what would you say, increasing or decreasing? I would say increasing. Check the table. Does the table match? The table has values like 0, 1, 2, 3, 4, 8, and 16. Those are positive. The values 1, 2, 4, 8, 16, I'm sorry, I did not mean to say 0, are also increasing. So it matches. Now, because velocity is increasing, what does that mean about the acceleration? Let me rephrase. This is a question about the sign of the acceleration. The sign of the acceleration is positive. How come? Well, that's because acceleration is not just the change in velocity over time. It is also the derivative of the velocity. And like we learned before, when the derivative of a thing is positive, that thing itself is increasing. So acceleration does double duty. It tells us not just, the sign of acceleration does double duty. It does not just tell us left and right or not moving. It also tells us if the velocity, the thing it's the derivative of, is increasing or decreasing. Similarly, velocity does that for position. It doesn't just tell us if we're moving left and right. It tells us if the position is increasing or decreasing. So we look at the table and the graph. Look at the graph, look at the table. What would you conclude about speed? You would conclude that speed is increasing. We have increasing speed. We could say speeding up. What we are not going to say is accelerating. And the reason why we're not going to say accelerating is because we don't want to get this confused. We use acceleration to determine if we're speeding up. We do not use acceleration alone. So forget about the word accelerating for what we're doing. We're going to talk about speeding up. We're going to talk about slowing down. We're not going to say accelerating and decelerating. Okay, let's continue this analysis for some additional situations. Okay, and this is situation 2. So situation 2, I'm not going to write in the table. We know what happens. The velocity is all those negative values. I take the absolute value, they become positive, 1, 2, 4, 8, 16. The graph is below the horizontal axis. So when I take the absolute value to get speed, the graph is now above the horizontal axis. So looking at the graph of velocity, that was the original graph, that is negative, it is below and decreasing because those values are getting more negative. Velocity, we just said, was decreasing. What do we know about the acceleration's sign? Well, the acceleration sign ought to be negative because it's the derivative of velocity. Now, take a look at the graph. So this is the velocity graph. This is the velocity table. Right, I didn't fill it in, that's okay. Would you agree that this graph is increasing? Would you agree that these values are increasing as well? If you go from 1 to 16, yeah, that's definitely increasing. So the next situation, we have the graph, we have the table. Check it out. Absolute value of negatives are positive, so the speed is 16, 8, 4, 2, and 1. Sounds like that is decreasing. If I take the absolute value of the graph looks like that. Yeah, that's the absolute value of that graph. So based on the graph and the table, we know that the speed is decreasing. Or you could say slowing down. Moving slower, decreasing in speed. All of those mean the same thing, okay? But let's go back. What did we start with? We started with velocity. Velocity is negative and decreasing. Since velocity is decreasing, the sign of the acceleration is negative. One more situation, and then we can recapitulate, analyze, and synthesize. I feel like synthesizing should be a sweet dance move. Okay, here's the last one. Velocity is positive. It's above the horizontal axis. It is decreasing. Look at that. Look at the values. Definitely decreasing. Because velocity is decreasing, like we just said, we know acceleration, its sign is going to be negative because that's the relationship between a function, the velocity function, and its derivative, the acceleration function. And if we look at the graph and the table, speed is decreasing. Yes? Okay. So if you go back looking over what we did, which situations did you notice the speed was increasing? We were speeding up. Which situations? When was the speed increasing? So there's 4 situations. Which ones? Well, we need to look at the last part of each situation to make that determination. Okay, let's start situation 1. Situation 1, speeding up, increasing speed, check. Situation 2, speeding up, increasing speed. Situation 3, decreasing. Situation 4, decreasing. So that's situations 1 and 2. What did you notice when the speed was increasing about the sign of the velocity and the acceleration? What did you notice was true about those? Did you notice they were the same? Either both were positive or both velocity and acceleration were negative. They have the same sign. Okay, so we know by process of elimination, we're talking about situations 3 and 4 for when the speed was decreasing. But we could quickly look back. Here's situation 4, we concluded decreasing. Here is situation 3, we again concluded decreasing, slowing down, speed is decreasing, speed is going down. What did you notice there? Hopefully you noticed that the signs of those things were opposites. And then I have a really important idea I need to make sure I communicate with you. And then an interesting analogy. So when you're speeding up and slowing down, we're not going to look at the speed. Instead, what we're going to compare is the direction of the velocity and the direction of the acceleration. You may wonder why that is. And the reason why is because it's awfully hard to get speed from velocity by doing the math of the absolute value. It's easy to do if you have a graph, it's easy to do if you have values, but if all you have is a function, it's really hard to do the absolute. So the analogy, imagine you're walking to school on a windy day, or just walking from the parking lot to school on a windy day. Imagine that's what's happening. So you're walking, and let's say you're walking into the wind. Walking into the wind is like having the acceleration be in the opposite direction from your velocity. So think about what that's like. Do you remember that experience? If you take a step back, it's not just a step back, it's a big step back because it's pushing you really hard this way and you're moving this way. So you're like moving faster when you're going backwards, getting jerked out of the camera screen, okay? But if it's behind you when you're moving this way, then you're going really fast. You're taking big steps. You're going super quick. And again, if it's against you, it's pushing against you. So think about that when you're trying to think about speed, when you're comparing velocity and acceleration. So when you've got a headwind or a tailwind. So in this case here, you've got a tailwind when velocity and acceleration are both negative because I'm moving left and the wind is pushing me left. Whereas in this situation, I've got a headwind. I'm moving right, but I'm being pushed left. So that's where the analysis of speeding up and slowing down comes from.